Testing, can you hear me? So last stream, I was reading the list ADT. So I was reading, wait, I was reading this book, all right? And then I was reading about list ADT and I was doing the exercise at the end, the programming exercise at the end. As soon as I start doing it, my stream got cut off. So basically, I kept on reading more and more, and then I realized my stream wasn't working. So just going to read from where I last left off. So they were talking about array-based list implementations and linked list. So using the class, they're making a class called array-based list. They're going to inherit all the methods of list, the insert, the remove, the make empty, clear content, and whatever. So what I was saying is that an array is just a contiguous, contiguous is like a list of values stored contiguously in memory. That's what it is. And there cannot be any gaps in between. So let's say this is something in memory. Hold on. Let's change the color. Let's say these are values stored in memory. There cannot be any gaps in between. They have to be stored one after another. This is the first element, this is the next, this is the next, this is the next, this is the next, and it starts with 0. Also, yeah. So over here, I'm going to use C++. They have a default size. And when we initialize a list, the list array, there are list item type of size. So basically, hold on, how do they specify the list item type? Yes. Okay, basically, if the list item type is integer, I would have integer of size 10. Let's say they did not specify the size, so the default is 10. So we have a list of 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Over here it's 13. Let's say we have 13. And the constructor, we delete the entire list. Clear, we just set the pointer position to 0. Okay, for insertion and removal, let's put this below. An insertion and removal, let's say I want to add a new element in position 0, 1, 2, 3, 4, in position 5, 6. Position 6, I want to add a new element, but position 6 already has an element. So all the position after 6 is shifted one element ahead. So I want to add a new thing here. So what happens? This goes one place ahead. This goes one ahead, one ahead, one ahead, one ahead, and then a new element over here. And then removal is the opposite. We get rid of this. I mean, we don't have to get rid of this. We just copy this, replace this with the what's over here. So if you want to remove it, we just copy this, place it over here, remove it from here, and then place it from here. Similarly, place it over here and remove it from here. Place it over here, remove it from here. Same thing. The value that was originally here gets overwritten. Okay. So that was the array-based implementation of a list. Now we are going to talk about linked list. So a linked has like two values. It's like, imagine an array of two values. The first one contains the value itself. The second one is the pointer to the next value. So there's a stack and a heap. So with an array, values are stored contiguously in the array, one after another. In the linked list, they don't have to be stored in contiguously. We just need to remember the location of the next value, the memory location of the next value. So these are called nodes. So the first node is stored somewhere. And the node contains two elements. It's an array of two elements. So first element contains the value itself. The next element contains the position of the next node. And the next node has the value of the next element and then the position of the third node. The third node has the value of the third element and then the position of the fourth node. And then so on and so on. If we want to add a new element, let's say between 3 and 4, we want to add a new element. So this is now 5 and we make a new node. I want to insert this over here. So what we do, we save this node somewhere, delete this, create this node, and then make sure this points to this, and then this points to this. So we inserted a new node. And then deletion is the opposite. We just make sure we save this value. We make sure that this points to this, and then we delete this. We deallocate the deleted node. Oh yeah, and what they're saying over here, instead of like, they have a special header pointer. So we pointer to the next element, pointer to the last element, but we want to save the first and last separately. So this one is called the head, and the pointer to the head is stored separately. And then this one is called the tail. The pointer to the tail is stored separately. But the thing is, what they're saying is that instead of this, we should have something like this, where you have a dummy node, which the header points to, and then the dummy node points to the first element. And then we have a dummy tail, and the last element points to the dummy tail. So the tail being the last element, it points to the element after the last element. Another problem is that we have no link to get us to the preceding node shown in yellow. So we have no easy way to update the yellow node's next pointer. Often we get around this problem during deletion by copying the value from the current node, in this case back in the current node. Let's look again at the example where we delete the value 10. Oh, they represent a linked list like this, where this dashed line shows the current position. So current position is here and it's represented by this dashed line. They want to delete 12, so they get rid of 10 and then make sure that this points to this. Delete that. Okay, what I was imagining is that this nodes get deleted and then the current points here, but they're doing something different. They're copying 12 over here and then deleting this. We have the current and date, but there is no way to update the next pointer of the node with value 12. There is no direct way around this problem with the list as shown here. This approach does not work when the current node is the last one on the list. Are they saying they cannot go back, but can't we just start from the header and keep looping until we reach current? Fortunately, there is a fairly easy way to deal with all of the special cases as well as the problem with deleting the last node. Many special cases can be eliminated by implementing linked lists with additional header node as a first node of the list. The header node is a link node like any other, but its value is a node and it is not considered to be an actual element of the list. The header node saves coding effort because we no longer need to consider special cases for the empty list or when the current position is at one end of the list. Also, the empty linked list looks like this. I have a dummy header and dummy tail with no elements in between. So linked list implementation, list link head, link tail, link current, link list. Wait, let me implement it. It's C with struct and functions. Struct, just the node. We have the, let's say it's an int node. Int node, we have the value, and we have struct int node be next. Yeah, I think that makes sense. And then we have a struct linked list. We have a dummy header node. I will just call it header. And then we have a tail. Should it be pointed to header or header? Tail, and then we have a pointer to current. Okay, let's do pointers instead. Is it a pointer or is it a... Okay, they don't seem to use pointers, but I will use pointers here. Tail. Current. So first, we make a new linked list. Struct. What is this? Struct. Linked list. My list. This will be new. Don't we use malloc? Hold on. Wait, I forgot how you do the thing. Size of This goes here. Size of linked list. And is it like this? Wait. Heap memory in C. We do use malloc, but what I don't remember is yeah, I don't think we use malloc for linked list. We don't use this. We use the node for the use it for the node, right? Linked list. My list. And it's stored in stack. Then my list dot malloc. My list dot header. I don't know if what I'm doing is correct because I can't remember much. I'll just call it head. Head, tail. How about that? A head and a tail. Where is the current point to? Current points to the tail. Can I do this? Current. Or is that less readable? Assign the head, assign the tail, and then if I want to add int to list, I should call it int link out. To ILL int value, and then struct. I hit this struct int linked list. List, and this is going to be a pointer. Let's say we add 5 to my list. To pointer to my list. And then let's set the current to the head. I'm going to loop through the entire list and print their values. The head and the current is not my_list.tail printf. Actually, never mind this. Current is not set for now. Printf %t/t my_list.current.value. my_list.current.value. And then the current becomes, my current becomes p next. See all elements. I should put this in a function. Void view all in elements. And then I should loop through this. This is more readable. My list. So I need to change this and okay, so I need to add 5. I haven't done this. So I create a new list. I'm thinking of how should I insert a list. Shouldn't current point to head? That is what I'm thinking. Wouldn't it make sense for current to point to head? So using current, right? You make a new thing. Because I'm thinking as I'm going along, I don't think I've ever written. I've only watched videos, but I've never like typed it in. Malloc int node. We make a malloc. Struct inode. New node is, well, the pointer is, so we have the pointer. And we have the current value. Okay, so currently it's like this. This is the head. This is the tail. Head. Current. Tail. Now the thing is I want to add new element. I have a new node over here. New node. Then current. Okay, whatever the current is pointing to, it will then point So whatever the current is pointing to, this will point to that. Sorry. Yeah, whatever the current is pointing to, this will point to that. So that's the first step. So new node, p next value of new node is list current, p next value of this. Right, next question is what current is pointing to. Instead of this, it needs to point to this. Current p next is new node. Yes. And it's done. So after I do this, no, it's not done. After I do this, I need to set current to this. So current is now this. So list dot current is now the new node. We start with p. We start with the value after head, and then we loop through. So let's say gcc test.c. I forgot to include Studio H because I'm using printf. Include as standard IO. Standard IP. Nope. Something is not right. The value of head. Okay, forget the value of head. List current is not the tail. Oh yeah, I also need to make sure that the head points to the tail. Yes. The current dot p next is my list dot tail. What is this? Current dot value. What's the issue here now? 1550. Okay, it does show 3 values, but it shows like garbage. Oh yeah, I did not set the value. New node p next, and then new node value. New node value is the value being set. There we go. Now for deleting the we also need to set the current element, right? We need to go back. No, we can't go back. Not with this structure, we can't. We need like a previous element as well. So, but we can go next. Position 0 is the one after head. Position 1, okay. So head starts here. Head starts here. Head would have no value. This is actually, it's better if I represent it differently. Slash. This points to tail. And then we have that. We have the head, which points here. I don't care about the value of head and tail. Let me see. I need to set. This is position 0, which is 1 after head. This is position 2, which is 2 after head. Set current position. Set the current position from 3. Int position. So we start with head. Start with head. Also, I need the list. Is it better before or after? Let's do before. Before makes sense. Ten, 20, 15. I actually like this. This is what I miss about programming. Do I have this right? Nope. Into position. Where is the error? 3. Set current position 3. What's the issue? Too few arguments in function. Okay, it's just not updated yet. So we start with the header. P next. That's the first element. And start int counter int counter is 0. Int counter 0. List current. So current is set to the thing after the first element. We should allow -1 though, to set the counter to before the header. set, wait, hold on. If it was 0, if the current position is 0, if I'm setting the current position to 0, I'm setting current here. Similarly, if I'm setting the current position 0, I'm setting it here. What is, yeah. What confuses me is that at the very start, I'm starting with here, right? If I'm adding a new element, I would add it over here. And this new element would be current. Okay. Counter is 0, position is 0. Should I save up the size also? And so if I do 0, this is the default, right? Or should I set the default? My list dot size is 0. Void create and get in LL. Return my list. Malloc. This is created on the stack, right? I think this will cause an issue. Pointer. Should I do it like this? I don't know if this makes sense. I actually don't know if this is correct. Okay. My list B is let my list be this. And then instead of this, we have Okay, let's remove this. Let's see if everything works. Yeah, it does. So set current position, mylist p. If position is less than 0, if position is less than 0, we return. I want to throw an error though. If position is more than list size, return. Print please in error position value received. Position list size list size. So we start with 0. And you start with 0. Wait. So the current is at the head. The current is at the head. We start the counter at 0. While counter is not positioned there. Counter P next. And then counter plus plus. Start with the head. And then if it's 0, actually it should start with a -1 maybe. It should start with -1. Head current.p next, and then the counter becomes 0. But the thing is, I'm getting confused with the just header and tail case and this case. In this particular case, current is pointing to 0. So if we had, I'm getting confused on where the current should point. If we have just head and tail, current is pointing here, or it can point here, it can point here. That I can understand. Where would it point when it's just head and tail? Should it point to tail because that's right after head? But adding a new element would be an issue, right? If it points to tail and we want to insert a new one, I have to start all the way from head. We have to start with one before. That's the issue. No, I think the current should point at head. List head. Okay, it should point at head. If list dot size is more than 1, so it's more than 0, to be next. Else this and return 0. So it points to 0, which is the first element. If that's not the position, then it goes to the next element and increments the counter. Five is, and let's do 2. And